Good day, grade 12s. I hope you are well. Let me welcome you to our technical mathematics lesson. I'm going to take you through analytical geometry today. And by the way, my name is Mr. Posa. But before I can take you through this analytical geometry, I just want to advise you that you should have by now examination guideline for technical mathematics. It's very important to have that document because it will help you a lot, because it outlines the importance information that you have to know for each topic under technical mathematics, right? And then if you don't have, you can get it from DVE website. It's there. All right. Let me just take you through this topic for today, which is analytical geometry. As you can see on the screen that we are having analytical geometry. Under analytical geometry, we have what? Linear analytical geometry. And then we have circle analytical geometry. And the last one, we have ellipse, right? Now, as you can see, that this topic, it forms part of paper 2. And then it contributes 25 plus or minus 3 marks in that paper, right? So it's very important that you understand everything under this so that you can get good marks on it. Now, I'm going to take you through what? Circle, analytical geometry, and ellipse for today's lesson, right? And then let's proceed and see what to get from this topic. All right. All right. Under circle and analytical geometry, we are going to learn on how to determine or find the equation of a circle or semicircle in form of x squared plus y squared equals to r squared. So after that, then we'll be able to do what? To find equation of the circle or a semicircle in the form of x squared plus y squared equals to r squared. Then the last one is determine the equation of a tangent to a given circle where gradient or a point is given, right? So those are two aspects that we'll be focusing on for today's lesson. Okay, we are now having example 1. Let's see what is for example 1. In this case, it says, in the diagram below, O is the center of a circle, P and Q is 12:5 are points. Let me just show you. Are 2 points on the circumference of a circle. POQ is a straight line, and the point R lies on the tangent to a circle at Q. So we can see this line here, POQ is the diameter of this circle. And then this RQ here is the diameter of a circle there, right? Then we are having questions for this scenario here. The first question says we should determine the equation of a circle. We should determine the equation of a circle, right? Now let's see on how do we determine the equation of a circle. First, we're going to write the standard equation for a circle, which is x squared plus y squared equals to r squared, right? Now, for us to obtain the equation of a circle, actually, we are looking for this r squared here. We are looking for this r squared. So once you have the r squared, then you will have the equation, the tangent, right? So we actually calculating for r squared here, right? Now, where do we get the value for x? Where do we get the value for y? So you are going to take any point that you see on the circumference of a circle. But in this case, we can see that we are only having one point there, which is given, which is q 12:5. Then we are going to use 12:5 for x and y so that we can be able to calculate r squared there. There, next step, you're going to substitute your x value there, which is 12, your y value there is 5. And the third step, you can see that 12 squared is 144 plus 5 squared is 25 equals to r squared. When you add them together, you are going to get what? 169 equals to r squared, right? Remember, we are looking for r squared so that we can have what? We can have the equation of a second. Now, the last step, we are now having what? We are having the equation of a second. So in this case, we are not looking for r squared, right? We are not looking for r squared. So once you just obtain the r squared here, which is 169 in this case, then our equation, it will be x squared plus y squared equals to 169. Then this is what? This is the equation of the second. It's very easy, very simple. All right, the solution for the next question that says we should calculate the tangent. We should calculate the equation of the tangent RQ. Where is the tangent? This is the line for tangent, which is RQ. We are looking for the equation of this line here. We can see this is a straight line, right? This is a straight line, right? In the form of what? In the form of mx plus c, right? In the form of mx plus c. Now, first, what do we really need for us to be able to calculate the equation of a tangent? First, we need the gradient. We also need what? A point, right? So we are going to look for a gradient and a point. Now, the first step, what we have to do, we have calculated the gradient of OQ. Where is OQ? This is OQ. This line here. We have calculated what? The gradient of this line. Why? Because we are having 2 points, right? Remember that you can only calculate the gradient if you have only 2 points, right? We are having coordinate of O here, which is 0:0, and the coordinate of what? Of Q, which is 12:5, right? And obviously the point, we are going to take this point Q because it is on this line that we are calling a tangent. So we are going to use that point, which is 12:5, right? So as for point, we don't have a problem, but the problem, we still have to determine the gradient of what? Of this line, of this tangent, which is RQ, right? And then the next step, all right, we have obtained what? The gradient now of QR, which is equals to -12/5. But how do we obtain that? Now you remember that if we have a line from center here, it's always perpendicular to the gradient, meaning they form 90 degrees there. This line here, which is OQ, is always perpendicular to the tangent, right? And then if that is the case, then we are going to use this formula here to calculate or to determine the gradient of a tangent. Now, it says the gradient of QR multiplied by the gradient of OQ equals to -1. So we all know that when we have what? The gradients of a perpendicular lines, they have the product of -1, right? Now, we can see that we are looking for what? We are looking for the gradient of this, which is gradient of QR, the gradient of a tangent. Then we have determined the gradient of OQ, which is 5, in this case, 5/12, right? Equals to -1. So you're going to use this formula to calculate the gradient of the tangent, which is QR. Yeah? Then in this case, we got what? We got negative 12/5, right? So we are now having what? The gradient as well as a point. So we can be able to calculate now the equation of a tangent. We first have the standard equation here, and then for y1, we're going to substitute with the value of y on this point, which is 5 in this case. And then we have m, which is the gradient, and our gradient that we have calculated, which is negative 12/5. And then as for x1 there, we're going to take the value of x on this point, which is 12 in this case. Then you substitute them, right? Then we're going to make y the subject of the formula, and then this -5 we're going to transpose to the right? And then here on the right hand side there, we are going to open this bracket with this negative 12/5. Then now you're going to obtain what? The equation of a tangent. Very simple, very easy, right? Now let's proceed and see. We are now having example 2. Let's see what we have under example 2. Right, example 2, it says in the diagram below, O, which is the center, and the coordinate of this is 0 to 0 there, in the center of the circle, and F, which is 10⁻⁴, is a point on the circumference. FH is the diameter of the circle, and GH is the tangent to the circle at H. Now let's see what type of question we might get. All right, the first question that we have to calculate or to solve it, it says determine the length of the radius of the circle. Now in this case, we are looking for radius. We have to calculate the radius of the circle. Then how do we go about it? Let's see the solution. First, we have to take the equation of a circle, which is x² plus y² equals to r², right? Because we are looking for radius, we can see here is r here, this is r, it means we are in need of this r there, right? Now, if you remember previous example that we did, I said that for x and y, where are we going to get those values there? We are looking for a point on the circumference of a circle, any point. But in this case, they have only give us the point F there, which is 10⁻⁴. Then you're going to use this point F for x and y in order for us to determine the value of r. Second step, all right, the value of x is here is 10, and then y is what? -4. All right, then you square them. 10² is 100, -4² is 16, equals to r². Then when you add them together, then you are going to get what? 116 equals to r². Remember, we don't need r², but we need what? We need r, which is radius, right? So next, we are going to put the square root in both sides because we want to get rid of this 2 here. This exponent 2, we want to get rid of this exponent 2. So we are going to square both sides. We put square root both sides. Therefore, the value of r, which is the radius, is equals to what? 2√29, right? That's how you should obtain or determine the length of the radius. The next question says determine the gradient of OT. So we are looking for the gradient of which line? This line here. We are looking for the gradient, yes. We are looking for the gradient of this line, yeah, right? Now, earlier on, I did explain to you that for you to be able to calculate the gradient, you need 2 points, né? You need 2 points. You need 2 points. Now, in this case, we can see that we've got the coordinate of O here, which is 0 to 0. But what about the coordinate of H then? We don't have the coordinate of H. But how are we going to do that? Let's see the solution. Now, the coordinate of H is -10:4. But how do we, where do they get that? So look at here, if you can check this point here. So the coordinate of F are the coordinate of H. It's just the reflection. Yeah, it's just the reflection there. But the only difference is the sign, right? But the value of x is 10. Here is going to be -10 because we know that x in this quadrant is negative. In this one, we are having -4, and then here is going to be +4 because we know that y in this quadrant is positive, right? We are now having what? We are now having the coordinate of H. So it's going to be easy for us to calculate the gradient now. Then we're going to say the gradient of OH equals to YO minus YH, then XO minus XH. Then you're going to substitute, and then you press your calculator. Then we're going to have what? The gradient, which is -2/5. We are now having the gradient 2/5. All right. So that's how we should determine the gradient. All right, now let's proceed. I think you understand everything. Let's proceed. Okay, the question still continue. Let's see the scenario and the diagram there. Now the next question says we should determine the equation of GH. Where is GH? Oh, this one. You can see GH is what? Is the tangent. Is the tangent. So we have to determine the equation of a tangent, right? Remember earlier on we did calculate the equation of a tangent, right? So by now you should have at least an idea on how do we go about it. The solution, okay, the gradient of HG, because we need the gradient of this line here, right? We need a point, we also need a gradient, right? But remember, previous example of question, where we have determined what? We have obtained the gradient of H there. The coordinate of H, I mean, we have obtained the coordinate of H there. It was -10 is to 4. So the only thing which is left, it was the gradient. So we have to calculate the gradient now. All right, the gradient of HG is now what? 5/2, right? It's 5/2. But how did we obtain that? Remember, earlier on we calculated the gradient of OH. We determined the gradient of OH. It was what? It was -2/5, right? Now, because this line here, this line is perpendicular to the tangent, it's perpendicular to this line of GH. So meaning the gradient of two lines which are perpendicular, the gradient of two lines which are perpendicular, they have the product of -1. You can see here. You can see this one. So now we are in need of what? We want the gradient of HG there, multiplied by the gradient of OH, which we have in the previous example, which it was -2/5 equals to -1. So when you solve it, then you're going to get what? We're going to get 5/2. So we are now having what? The gradient of GH, right? Then the point you're going to use, which point? Point H, which is -10 is to 4. Then write the standard equation for straight line, which is where you see y1, you're going to take this 4 here, and then the gradient is 5/2, and then x1 is -10 there. The next step, you're going to substitute there, and this is what you're going to have. And the third step, we have to make y the subject of the formula, whereby you're going to transpose this -4 on the right hand side, and then this is what you're going to obtain. And now we are having what? We are having the equation of GH, this tangent. We are now having the equation of this line here. All right. Now let's proceed. All right. As for circle and analytical geometry, we are done. We are now into ellipse. So we are going to be focusing on ellipse. Now, what do we have to learn from this ellipse? First, we are going to learn on how to plot the graph of ellipse. We are going to learn on how to plot the graph of ellipse. To write the equation of an ellipse in the form, in a standard form. Write the equation of ellipse in the standard form. Which standard form? This one here, which is x squared over or a squared plus y squared over b squared equals to 1. Right? Then on the right hand side, you can see we've got two what ellipse. The first one, which is this one here, is the horizontal ellipse, and the second one here is what? Is the vertical ellipse. All right. Can you see that? All right. Now let's proceed and see what will we get, and then example 1 there. Okay. Now, if you remember, I said we are going to learn on how to plot the graph now. So the first question says we should sketch the graph defined by this. So now when we're having this, then they ask you to sketch the graph. Then how are you going to do that? Right? How are you going to do that? Now, let me take you through the solution on how do you draw the graph for ellipse. Now they say when the bigger number is under x, the ellipse is horizontal, and when the bigger number is under y, it is vertical. Right? You remember from previous slide there, we had two examples of what? Of ellipse. The one which is horizontal and the one which is vertical, right? Now, but this one, we don't know as whether it's going to be vertical or it's going to be horizontal. But how are you going to know that? It says when the bigger number is under x, the ellipse is horizontal. Now let's come here. Which number is bigger? Here. So there is a number which is bigger under what? X. Meaning the ellipse that you're going to plot is going to be horizontal. All right, it's going to be horizontal. All right, for example, it's this one. You can see we've got different. We have two types of what? Ellipse. The first one is the horizontal one, right? Where our vertices is going to be on the major axis. You can see that this point is going to be the first vertices, and this was going to be first vertex, and then you can see that it is on what? On the major axis, on the x-axis, right? And then the core vertices, it is on this line, what you call it, a minor axis, right? Now we have agreed that this graph here is going to be horizontal. Why? Is because the bigger number is under x, and that number you can see is 4 there, right? So we are going to have a ellipse which is similar to this structure here. Can you see that? All right. Now, it says this is the horizontal ellipse, as the bigger number is under x, right? Now, we have to rewrite the equation so that the denominator are shown as squares, and we can identify what is the value of a there and what is the value of b there, right? Now let's proceed. All right. Now we can be able to see the value of a there, which is 2 in this case, and then the value of b is what? Is 1, right? Remember from the standard equation, because the standard equation says x squared over a squared, right? But remember we had what? We had 4 there, right? But to write it in that form of a squared, so we're going to have what? 2 squared, so that we can be able to know the value of a, right? Now we can see the value of a in this case is what? Is 2, and then the value of b in this case is what? Is 1, all right? Now, after we have determined the value of a and b, let's see, and then say the 4 points we need to plot in order to sketch the ellipse are, we're now heading to draw the what? We're heading to draw the ellipse now. Then it say the coordinate for the vertices are first 2 is to 0 and negative 2 is to 0. You can see these are vertices that we'll get from the major axis, right? The major axis. So in that line, you remember is the x-axis, né? So in that line, we know that the value of y is 0. Hence, we are having 0 here and 0 there, right? And then what? The core vertices are 0 to 1. Then you can see here, I also tried to show you where do you get the core vertices. Is this point here, and then this point there, right? And then the same applies with what? Vertices. Where do we plot them? The first vertices, we're going to put it here, and the second one, we're going to put it there. Thereafter, you're going to join all those points. Then you'll be having what? The ellipse graph, right? Now let's see. Now this is the solution for this question. So this is the ellipse we are looking for, right? If you can check the first point there, it was 2 is to 0. Where is 2 is 0? Is this point there. We just put a dot there. The second point is negative 2 is to 0, which is this one here. And then the other points, which are core vertices, which is 0 is to 1, where 0 is to 1 is this one, is this point. And the last one is 0 is to negative 1 and this point, right? So after putting your points, you just join them. You're going to join them, and then they're going to give you a nice ellipse graph. You're going to have a nice ellipse graph, right? Then that's how you should draw an ellipse, right? So it's going to be easy. What is important here actually is to know the value of A and B. Once you have the value of A and B, then it's easy to plot the ellipse graph. And make sure that on the right-hand side here, it's always 1. If it's not 1, then there's no way we can just proceed and draw an ellipse, right? Okay, thank you. Let me proceed. Now let's go example 2. All right. Now, it says write down the equation in the standard form of this. Now you have to put in the standard form. Look now what we're having in this case. Something new that we are having, but we should put it in this standard form, right? And earlier on, I also explained that make sure that on the right hand side you have got what? 1. So in this case, it's not 1, but it's what? It's 36. But we'll see on how do we do that. The next step, we are going to divide both sides by 36. Why 36? Because on the right hand side, remember, we have to obtain 1. So the only way to get 1 on the right hand side is when you divide that number, this 36 with 36, right? So it's going to be 36 divided by 36. Okay. The next step, then you are having this. So it means in this case, we said 9 is to 9, 1. 9 to 36 is 4, right? 4 into 4, 1. 4 to 36 is 9, equals to 1. So now we are having a normal ellipse equation there, right? But remember, we should write it in this format, where you can be able to see the value of A squared, the value of B squared. Now we are having 4 and 9. Then the last step, we can now see the value of A in this case is 2, the value of B in this case is 3. So that's how you should write it in the standard form, right? Okay, you can have this activity and then just to test yourself as to whether you can be able to apply what you have learned since we have started this lesson. All right. Grade 12s, this is your message for today's lesson. That says study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late. So please, let us study and study and study and study every day, so that we prepare ourselves thoroughly for these coming exams. All right. Thank you very much.